This is problem 7-55 from section 7.1.4 homework. It says the measure of angle ROS in triangle ROS below is 60 degrees. Let's draw that in here. ROS is right here. And then this guy is 60 degrees. Right in this corner. Okay? So the curved arrow represents the rotation of beginning from the positive x-axis. So I know my whole circle is, it really says the rotation of OR, so really it's talking about this. That was not, that just, I guess, didn't get copied into the words here, so this is really OR. So the rotation of OR from the positive x-axis. So if I'm looking at that, that's from here, I'm going all the way around to land here. And so what we want to know is how many degrees did it go? So if it went the whole way around, that would have been 360 degrees. But it went how many degrees short of that? I'm going to take away my 60 degrees of the triangle. So that's going to leave me with a 300 degree rotation. So that's for part A. It's really 300 degrees. Okay, 360 is my whole circle minus how much of the triangle went there. Okay. So part B says if OR is worth 1, which is going to be my radius, right here, this is worth 1, what are the exact lengths of OS and RS? The exact length of OS. This is my horizontal distance. I know my angle of this little triangle, I know that angle was 60. So what I'm going to do to find the horizontal distance, take the cosine of 60. Okay. Now it says the exact length, but let's just for fun see, maybe this is going to give me like a nice number. I don't really know. So let's figure out cosine of 60. Here we go. Cosine of 60, remember we are in degrees, gives me 0.5. Or, when I'm talking about exact, it really likes us to be using fractions. So I could call this 1/2. That is the length of OR, right there. OR is 1/2. So in my triangle right now, I know one of the sides is 1/2. I know the hypotenuse is 1. So my third side, which is really SR, now it's talking about the length of it, so I'm not going to talk about a negative length. If it asks me for the coordinates, then I would have a negative number since it's in the bottom, but length is just going to be considered positive. So I know 2 of my sides, so I'm going to just kind of recreate our triangle down here. Okay. This I know is 60. Since this is 90, I really know that this angle is also 30 down here. Okay, 30, 60, 90. We know this guy's 1. Now I know this is 1/2. So I can use the Pythagorean theorem to find the exact length. I know one alternate way to write the exact length for the horizontal is, or the vertical distance is sine of 60. That would give it to me, but I'm having a feeling that's not going to be an exact number. So let's try it. Sine of 60. And I don't want, if it's decimal, see it's a decimal, I don't want to round that. So I could either leave my answer as sine of 60, or let's try using our Pythagorean theorem to get the last side, right? So I have 1/2 squared plus, we'll call it side B squared equals 1 squared, really, because that's just the 1 squared is 1. So remember, I'm not going to do these in decimals because I want exact lengths. So I'm going to take 1 squared, or 1/2 squared. Let's get a little more room between these things here. Okay, so 1/2 squared is going to be 1/4 plus b squared equals 1. So if I take away 1/4 from both sides, I know I'm left with b squared is going to equal 3/4. And if I take the square root of both sides, I do not know the square root of 3, but I do know the square root of 4 is worth 2. So this is really worth radical 3, or square root of 3, divided by 2. So this is really my length of SR, or this third side. Okay, so I know the side length, the exact side length of OS, which was my horizontal distance. Right here I found that was 1/2. I know this vertical distance is the square root of 3 over 2. Okay? So part C says what are the exact coordinates of point R? So we talked about the coordinates being the cosine and sine, or horizontal distance and the vertical distance. Now, what's different here, it's not just going to be the same exact numbers. Now I know the horizontal distance here was 1/2. I know this distance was radical 3/2. But when it's talking about coordinates, that's when I need to take into consideration the direction. Okay? So from the center of our circle, this is positive. This is moving to the right, it's positive. But here, this is going down. So the coordinates of this point are still going to be 1/2, because that was positive. But my distance is going to be in the negative direction vertically. So it's negative radical 3/2. Okay? So it's still the same values, but when it's the coordinates, that's when I want to think about which direction I'm going. Okay, so this is problem 7-55.